The second portion of section 4.3 is beginning on page 26 of your course notes. First, we have a little bit of review. So this portion is not in your notes. It's just a little review before we get started in a new video. Some important things. So it says if f of x equals x to the n, then the derivative of f of x, we take the exponent and multiply it out front. So this exponent would be multiplied in front of the term, like here, and we reduce the exponent by 1 degree. So subtract 1 from the exponent. If we have the product of two functions, u of x times v of x, then we take the first term times derivative of the second term plus the second term times derivative of the first term. Now a reminder, since this is a product and an addition, the order you do it in really doesn't matter. So if these two terms were flip-flopped, your answer would still be correct. So the point is you take the derivative of 1 multiplied by the opposite one, then alternatively take the derivative of the other term and multiply it by the original of the first term, if that makes sense. Okay, so now when we look though at the quotient rule, the order does matter because it's a subtraction, not an addition. So here we have the denominator times the derivative of the numerator minus the numerator times derivative of the denominator divided by the denominator, not the derivative, the original denominator, squared. Okay. And then if we have a function within a function, so g of x is inside of f, then when we take the derivative, we take the derivative of the outer function, so the derivative of f, leaving the function on the inside alone, and then multiply by the derivative of the inner function. Okay, so these are some rules that we have learned thus far in class. Is right here. So we have the denominator times the derivative of the numerator minus the numerator times derivative of the denominator divided by the denominator squared. So we start with the denominator. So beginning on page 26, we have an example. It says if y equals x squared times the square root of 1 minus 2x, find the derivative of y. Okay? So it says write it out the long way until you get the hang of it. So when they say the long way, I think what they mean is by writing, instead of calculating the derivative, write the d in front so that we know we are taking the derivative. I'll show you one example. You do not have to do it that way, but it is sometimes helpful depending on, kind of depends on the person. Okay, so regardless, we have a product. Okay, x squared times, if we want to put a times in there, we could. X squared times the square root of 1 minus 2x. And then this 1 minus 2x is a function inside another function, right? It's inside the square root. So we're going to have to apply a few different rules. So our product rule says we take the first term times derivative of the second term. Okay, so I'm going to write it as dx of square root of 1 minus 2x. So that means that we need to take the derivative of this second term, okay? Plus the first term times dx of x squared. Okay, so if we want to write parentheses around those so they don't get, so we know which ones the derivative applies to, we can. Again, you don't have to do this step. You can just write the derivative if you would like. Okay, so the first term times the derivative of the second plus the second term times the derivative of the first. Now, we didn't have to apply the chain rule or anything yet with that square root of 1 minus 2x. We're just worrying about the multiplication at this point. So then the next step, we take the derivative here of 1, the square root of 1 minus 2x. So we're going to take the derivative of the outer function. So remember, we'll do this off to the side. Square root of 1 minus 2x is the same thing as 1 minus 2x to the 1/2 power. So when we take the derivative, the exponent will come in front, and then we will decrease the exponent by 1. Okay, so when we do that, we get 1/2 times 1 minus 2x to the negative 1/2. 1 minus 1/2 is negative 1/2. And then we would multiply, using the chain rule, we multiply by what's the derivative of the inside function. So the derivative of 1 minus 2x, which would be a negative 2. Okay? That's just the first term. Then we have the second term. So our second term, we have square root of 1 minus 2x, we leave alone. And then we have d dx of x squared. So the derivative of x squared is just 2x. I'm going to write it in front of our radical to signify that it's multiplying it. So now we just need to simplify as much as possible. So this first term, we have a 1/2 and a negative 2. We can simplify those. So 1/2 times negative 2 would be negative 1. So we'd have a negative x squared, that x squared in front, times 1 minus 2x to the negative 1/2 plus 2x times square root of 1 minus 2x. You really can't simplify any further than that. So that would be our final answer. Okay. If you wanted to take it a step further, you could put this negative exponent in the denominator. And we could do that just for algebra review. But we'd have negative x squared divided by square root of 1 minus 2x. So in the negative exponent means we bring it to the denominator. And it's the 1/2 exponent, which is the same as the square root. Okay, so then our second term, anything to still, so we will leave our answer like that. Either way, MyMathLab will accept your answer, and either way, they are correct. The point that we're learning right now is taking the derivative, not necessarily 100% complete algebra. U times derivative. Okay, and then still on page 26, we have a few more examples of the chain rule. Well, all the rules we've learned so far. So again here, if you look at it, we have the product of two terms. We have 4t times 2t to the 5th plus 3 to the 4th. So we have a composite function and just a nice easy function 4t. So when we take the derivative, we get the first term times derivative of the second. Okay, so first term times derivative of the second. When we take the derivative of, let's do it in red so we can follow what we're doing. Okay, we multiply the 4 out front, and then we decrease the exponent by 1, and then we multiply by the derivative of what's inside the function, the chain rule. So now we're multiplying by the derivative of 2t to the 5th plus 3, which would be 10t to the 4th plus 0, or just 10t to the 4th. Okay. Then the next part is we add the derivative of the first times the second. So derivative of the first would just be 4, and then just times the second term. I don't know if these color coordinating things help you see which function is which. That's the goal of it. If it's distracting, I apologize. Okay, so now we want to simplify as much as possible. So this first term, we have a 4t, a 4, and a 10t to the 4th that we can multiply in front of this binomial. So 4t times 4 is 16t. 16t times 10t to the 4th would be 160t to the 5th. And then we would just leave our binomial as it is. And then we have this plus 4, 2t to the 5th plus 3. Now, at this point, it really looks completely simplified. However, often your book and will continue to factor this out. So in other words, there is a common factor of this term. Okay, there's 3 in the first one and 4 in the second, and then each of these could be divisible by 4. So if we factor out a 4 and a 2t to the 5th plus 3 from each term. So again, when we factored out from our first term, the 160t to the 5th divided by 4 would be 40t to the 5th. And then we're factoring out the 2t to the 5th plus 3 to the 3rd. So that term is completely gone when we're looking at our first full term, when we're looking at this first full term. And then when we factor out the 4 from our second term, that is gone. And then we're factoring out 3 of these 2t to the 5th plus 3 terms, so we're left with 1 remaining. And be careful, we are dropping the plus. It's not a product. We are adding these things. Okay, so looks like there's nothing we can simplify anymore. Oh no, we can. I missed this. These are the same terms. They're both t to the 5th, so we can combine those. R prime of t equals 4 times rt to the 5th plus 3 quantity cubed, and then we would have 42 t to the 5th plus 3. And that would be our final answer in simplified form. The derivative of... All right, part B. P of z equals z times 6z plus 1 to the 4/3. So again, very similar. We have a product, z times 6z plus 1 to the 4/3, and we have a composite function. So 6z plus 1 is inside the function with an exponent of 4/3. So when we take the derivative of it, we have the first term times derivative of the second. So when we take the derivative of the second, we're going to multiply the 4/3 in front, decrease the exponent by 1. So 4/3 minus 1 is 1/3, right? 4/3 minus 1 is the same thing as subtracting 3/3, so we get 1/3. And then we multiply by the derivative of the inner function. So the derivative of 6z plus 1 is 6. Okay? And then the second half is we have the derivative of the first term. So the derivative of z is just 1. That makes it nice and easy. And we multiply by the product, we multiply 1 by 6z plus 1 to the 4/3, the original second function. Okay, and then we simplify. Okay, so we would get p prime of z equals 4/3 times 6. We can cancel these, the 2. 6 divided by 3 is 2, so 4 times 2 is 8. So we have 8z times 6z plus 1 to the 1/3. And then our second term, we don't simplify at all. There's nothing we can do to simplify that. Okay, so that would be our final answer. This one was a little quicker, a little less algebra heavy. And that would be our solution. All right. First, the new third problem. Now we have a quotient, so there's plenty of algebra in this problem. So our quotient rule, if we go back to that numerator, so 4t squared minus 1 denominator times derivative of the numerator. Notice in the numerator we have a chain rule, so we have 2t to the 3rd, 2t plus 3 to the 3rd power. So we multiply our exponent out front, decrease the exponent by 1, and then multiply by the derivative of what's inside the function. So the derivative of 2t plus 3 is 2. Then minus the numerator, exactly as it is, times derivative of the denominator. Derivative of 4t squared minus 1, we just have to look at the 4t squared, so we get 8t. And then divided by denominator squared. Okay, so now let's see if we can simplify or combine any like terms. We have a 3 and a 2 here we can multiply out front. And our second term, we could just write the 8t out front, divided by 4t squared minus 1 quantity squared. And really there's no point. Let's see. Could we do anything? Oh yeah. We could take out this like we did in part A. We could take out this from each term, right? The 2t plus 3 squared. We could take out two of them. We could also factor out a 2 because there's a 6 and an 8, but let's not do that. Just because it won't help us all that much. Okay, so from the numerator, we're going to factor out a 2t plus 3 squared. So then we would be left with 6 times 4t squared minus 1. And then minus 8t. And again, like part A, we're left with 2t plus 3 to the first power. Okay? Divided by our denominator. Okay. So now we can distribute the 6 inside here, distribute the 8t, and then combine any like terms we have within these set of parentheses, and that would be our final step. So I'm going to have to start writing a little smaller here. So we have 2t plus 3 squared times 24t squared minus 6 minus 16t squared minus 24t. Now I'm not going to write the denominator for the sake of room. So we have 2t plus 3 quantity squared. Notice we can combine 24t squared minus 16t squared to be 8t squared minus 24t. Why do I have a plus here? Hold on a second. Let me back up. That is not a plus. So we're multiplying by this whole thing. 2t plus 3 squared times 8t squared minus 24t minus 6 divided by our denominator, which is 4t squared minus 1 quantity squared. So that's our final answer there. A little bit algebra heavy. So that concludes section 4.3.